In the name of God, my name is Mehdi Kordnavasi, and this is the second movie of the Introduction to Database Management System. Let's start with type of entity set or type of tables. There are two types of entity set. A string entity set. We say this table is a string if the entity have any key attributes. In this example, entity student have three attributes: register number, name, and address. And because the unique key as a register number included, we say this as a string entity set. The next is a weak entity set, having no key attributes. Here is an example. An entity named table have four attributes: shape, height, color, and width, but none of which are key or unique. So we say this table or this entity set is a weak entity set. A weak entity set is always associated with another entity set. We will use this table and to make it meaningful with combination of another table to make some relation. This another entity set is known as identifying entity set. We say as the identifying entity set. Let's have a quick view about the elements of a diagram. We need to draw a diagram, and the first is a rectangle. One rectangle. We will show each entity set or a string entity set with a rectangle. Double rectangle we will use as a weak entity set. And ellipse we will show attributes or characteristics or fields with ellipse. And diamond we show the relation between the two entities via the diamond, single diamond, and double diamond identify the relation type. For example, one to one or one to many. And double ellipse for a multi-value attribute. And a dash ellipse for a calculated or derived attribute. And the ellipse with the line inside we will use as a key attribute or key fields. And for a composite attribute we will use more than one ellipse connect to the only one. And the double lines we use as a participation, and the single line as a partial participation. This is a total participation, and this is a partial. So if entity 1 relates with entity 2 and relation be a 1 to n or 1 to many, for each record of E1 in this relation we will see all related records. we say as a total participation. But in this shape, only the first item will show. And the triangle we will use as a specialization or generalization. Let's see some example to have a better understanding. In this diagram, we have two individual entities. Entity 1 is a customer and entity 2 is the item. So a customer can purchase many items, or one item may be purchased by many customers. So here is a relation between two entities, a customer and entity item. We name this relation as a purchase, or any name you can assign. So let's see the attributes of a entity, customer entity. Date of birth, one field. Phone number is a multi-value because each customer may have more than one phone number. And customer ID, underline, shows customer ID is a key or primary key for the customer entity. And the composite field name, including three separate fields, first, middle, and last name. And a calculated or derived field name, age. So how many fields I need to define this table? Let's count. Date of birth 1. Phone number, we cannot define this as a one column in table because we cannot store more than one value in each cell. So we need a separate table and relate to the table customer to save multiple phone number for each customer. So date of birth 1, customer ID 2, first, middle, and last 3, it shows 5 fields. And age, we cannot define a cell as an age, but in queries or when we need to retrieve the data, we will calculate the difference of the date of birth and system date to get the age. We say as a derived field. The next, for the entity of item or good, we have 4 fields: weight, color, cost, and item code. Item code is a primary key or unique. Suppose in an Amazon field, Amazon database, each item have a unique code. And here is a purchase, a relation. I need to relate both of parties, both of entities via a intermediate table or relation. So if I define 4 fields for this table, one as a customer ID, the second as an item code, and 2 is a bill number and purchasing date. So in this table or in this relation, customer 1 via the bill number 1 and purchase date 1 purchase the item 1, for example. Again, same customer 1 with same bill number and same purchase date purchase the item 10, for example. And if I want to know which item purchased by which customers, I can order this table according to the item number and find the related customers. Let's see another diagram. Here there are three separate entities: customer, loan, and payment. Here is a bank enterprise, and we define three separate entities. For the customer, we have a multi-value name. It shows a customer have more than one, maybe more than one name, but an address and a unique ID for a customer in the bank. Each loan have a unique loan number, loan amount, and loan type, and each payment have a unique payment number, date, and amount. But we need two relationships. The first we name as a borrower relation. It connects two items, customer and loan. So if I add two fields to this table, the first customer ID, a key of this entity, via a loan number, a key from another entity. So customer ID 1 have loan number 1, for example. Customer ID 1 have loan number 10. Customer ID 1 have loan number 15. Customer ID 2 have loan number 45, for example. And the relation here is a one to many. And again, a loan is connected via the relation a loan payment to the payment attribute. So the loan number 1 have 4 payments, for example. Payment number 1, payment number 10, payment number 20, and payment number 30, for example. So if I add two fields to this table as a relation, including the loan number, the primary key from that entity alone, including the payment number, primary key from another entity in this table, I can connect two tables as a relation, and I name this relation as a loan payment. So if I have a loan number, a specific loan number, I can trace all of the payments via this table, because the repetition of the loan number in this table with their separate payment numbers. Here, cardinality ratio is many to many. Why? In this, the first item, because a customer can buy any number of items and same item can be purchased by more than one customer. The limitation of ER model. ER model cannot express relationships between relationships. In other words, ER model is not capable to express relationship set between relationship set. This limitation can be overcome by using EER or Enhanced Entity Relation Model. Let's see. EER is basically the enhanced version of ER, and all the basic concept of ER model with capability to support additional semantic concepts for the complex application. The additional concepts are specialization, generalization, and categorization. Let's see the another concept, and for the next slide we will discuss about these three concepts. The first, we need a superclass, super type entity, and I name it as a parent or base class. This is a general or generic entity type, include one or more distinct subclass that require to be represented in a data model. It means members belong to subclass are same as the entity in a superclass. The relation between a superclass and subclass is one-to-one. In some cases, a superclass or parent can have overlapping subclasses. Let's see in the next slide, example of a superclass. So if I have a base class here or superclass, this shows me these both entities have the same attributes of the superclass, and they have a special unique attributes more than the shared attributes. Subclass entity, a more specialized entity. Here is a more specialized entity that has a distinct role in the organization. A subclass is a member of superclass. It is one of the data modeling abstraction used in EER. A subclass may be further divided, and in that case it acts as a superclass for each subclasses. So here is a relation between parent and child. A parent have many children. Each child inherits the attributes of each parent. And again, a child can be a parent of another child, and the hierarchy is unlimited. Let's see example. In this diagram, we will talk about a bank enterprise. In a bank, we have an entity named person. A person have four items or four property or 4 fields: person ID, name, address, and age. In the bank, we have 2 types of person: employee and customer. So, because the employee is a subclass of a person, or employee is a child of a person, so this entity in this level have 4 fields from the parent: age, address, name, and person ID, and 1 more field named salary. So the employee is a special type of person. Another special type person is the customer. Again, customer have 5 fields. 4 fields come from parent: person ID, name, address, age comes from person, and 1 field more: credit rating. At the next level, we have 2 types of employee: full-time and part-time. Full-time employee have the parent fields, so the full-time employee have a 5 fields: salary, and 4 fields from here, and 1 more field: rank. So the employee for full-time employee have 6 fields, and the part-time employee also have a 5 fields from parent, salary, and 4 fields comes from here, and 1 more field type. Again, full-time employee, we have 2 types of full-time employee in the bank: manager and staff. Manager have how many fields? 1, 2, and 4, it means 6 comes from parent, and 1 more field: qualification. So manager have a 7 fields. The staff also have a 7 fields, but its special field is a staff ID, or maybe have more than 1 special field. And the part-time employee, we have 2 types of part-time employee: sales and collection. And the sales, how many fields? 1, 2, and 4, means 6 fields come from parent, and 1 more field: target. And for the collection, also same. Let's back to the customer. We have 2 types of customer: investor and borrower. Investor, we have 2 types of investor: saving account and current account. We have 2 types of borrower, or 3 types: education loan, business loan, and personal loan. Education loan have 1, 2, and 4. 6 fields come from here, plus a field named time. Business loan also have a special field: amount, including 6 fields from the parents, and so on. So look at the arrow. When we move through from the top to the bottom, from top to the bottom, we are going to a specialization of the entities. We will add more special fields. But when we moving through from the bottom to top, we are doing to generalization. And in this picture, we show the usage of a class and superclass, or parent and child. Suppose if we didn't use same concept for each of these entities, we have to add a lot of fields. For example, for this field, this entity, I had to add 4 more fields here. Again, 4 more, same 4 fields here. And for this item, I had to design 5 attributes here plus 1. So the graph will be too crowded and we will confuse to understand the relation. But by using the class and superclass and base class or subclass, we summarize the picture and make it easy to understand. As a conclusion, consider the example of a bank in which person entity is superclass entity type, which is further divided into employee and customer. Here, employee and customer entity are subclass entity type of person. Basic concept in the ER model: a person belonging to a bank is known as is known, and by EER, how it belongs to bank is known mean. What is the exact relationship between bank and a person? A person may be an employee or customer, which can be further categorized into manager, staff, and investor, borrower, and so on. Here is the difference of a EER model and ER model. Attribute inheritance, specialization, and generalization lead to attribute inheritance between higher level entity set and lower level entity set. Inheritance is a process by which lower level entity set inherits or taken some properties of its higher level entity set. Here entity sets employee and customer inherits attribute person ID, name, age, address from person entity set, as I touched before. Okay, thank you to watching this movie, and for the next movie we will talk about the producing tables from the ER or EER diagram. Thank you.